SimScale can be used to evaluate the thermal performance of a mild hybrid electric vehicle inverter, and this can include joule heating, conjugate heat transfer, and additional physics. Today, we will be evaluating the performance of a liquid-cooled inverter. This inverter has about 12 MOSFETs with 19 watts of heat load on each, as well as 22 capacitors with 1 watt of heat load per. In addition, we have several bus bars, which we can see in orange in the image. Each of them are handling 70 amps of current flow, and this is liquid cooled by a water glycol mixture. As a design engineer, we are trying to evaluate the thermal performance after a slight modification to the water jacket or fluid manifold used to cool this analysis. Let's go ahead and jump into SimScale to set up our simulation and view some results. I'm going to start at the SimScale dashboard. With a SimScale account, we have unlimited storage and unlimited compute capacity. We see my project here as the MHEV Inverter cooling, and we can go ahead and launch this project. Now I've already run this analysis, so let's go ahead and look at some results. As I've mentioned previously, I usually am interested in starting with global temperature. We will first start by looking at the temperature range on the bus bars. As we can see here, we have a bit of variation in these bus bars. Remember, each one of these has about 70 amps going through it, and we can identify that while the bus bar closest to the fluid inlet is operating at about 26 degrees Celsius, some of the bus bars farther away from the water jacket are at much higher temperatures, about 6 degrees higher, maybe 7 degrees higher. There are other bus bars which are sort of in between, with some parts of the bar having lower temperatures and some parts having higher temperatures. This can lead to thermal stress and expansion over time. However, generally speaking, these bus bars have relatively low temperature delta on them and are not excessively hot. Next, we can evaluate the MOSFET and capacitor temperatures. I'm going to next actually hide the water jacket and manifold, which we can see here, just to get a better view of the MOSFETs underneath. First things first is the capacitor temperature. Although we see a lot of red here, we can see each one of the capacitors is relatively uniform in temperature. If I just adjust the legend a little bit, we can see most of these are actually operating in the 42 to 43 Celsius as a maximum temperature on the capacitors. One item worth noting is that the temperature range on each capacitor is actually quite large. For example, down towards the bottom, we're at a high temperature of 43 Celsius, whereas at the top, they are closer to 28 degrees. Again, this could cause damage over time due to thermal expansion or thermal cycling, and ultimately can cause fatigue. Next, let's actually view the temperatures of the MOSFETs. This is most easily done by viewing the top of the board and actually hiding the bus bars. Here we can see a relatively uniform temperature across all the MOSFETs. Notice that I've tightened up the temperature range on the legend. For example, the highest temperature observed is roughly this 30, just under 31 degrees Celsius. Meanwhile, the coolest MOSFET observed is probably somewhere around 26 Celsius. Note that a temperature delta of just around 4 degrees or so is very low, and therefore the performance of all the MOSFETs and life of the chip will be similar. Next, let's go ahead and take a look at the setup. The first step to setting up a simulation in SimScale is importing your geometry. SimScale works with every major CAD package that's out there, including SolidWorks, Inventor, Creo, NX, Onshape, and so on. Note that we support all of these formats natively. However, we do also support StepFile, Parasolid, ASYS, and so on. Now that we have our fluid region, we are ready to choose our physics. This will be a conjugate heat transfer analysis, so I'll select these physics and then create a simulation. Next, we'll work down through the simulation tree, filling out some of the missing information. So for example, we are working with water as the fluid. And on solids, we can start to do material assignments. For example, aluminum. Now that we have all of our material assignments, it's time to move on to boundary conditions. As I mentioned previously, this is a liquid-cooled analysis. We will set the mass flow rate and supply temperature here. Next, we will pair it with a pressure outlet boundary condition to allow the hot side of this fluid to exit. Next, we will launch a simulation. When we kick off a simulation on our cloud, we get an estimate for how long the analysis will take, and the moment we hit start on the simulation, we can close our web browser and wait for an email in our inbox when the simulation is finished. Because you are using SimScale, you can run multiple simulations at a time, and there is no need to deal with a queue or wait for one simulation to finish before another starts. For example, I can start to parameterize the flow rate of the water jacket here. By setting up 5 different mass flow rates for the water side, I can now start a simulation, and this will actually be called an experiment, implying that I have parameterized a certain operating condition. With a single click of a button, I am now starting 5 simulations instead of just one, and again, I take no time penalty due to the fact that I'm running 5 simulations. In other words, these 5 will finish in the same amount of time as my first simulation run. Now, if at any point along the way you get stuck or are not sure if you can trust your results, you can reach out to us in our in-product chat. We staff this with simulation experts who are usually mechanical engineers with 5 or 10 years of simulation experience. With a professional license, your projects are completely private. However, if you want to share your project with the support staff to get some direct feedback, all you need to do is check this box here. This will allow us to see what you're working on and give you direct feedback on your project. You can always unshare your project and it will become completely private even to the support staff again. Thank you and have a good day.